Question number 6. Consecutive odd numbers P and Q are continuous odd number. P must be greater than Q. We are going to prove P square minus Q square is a multiple of A. Let us consider the two consecutive odd numbers. Let P equal to 2n plus 1 because which is a multiple of 2 plus 1. So the Q is always Q. P must be greater than Q. So consider the next number Q is 2n minus 1. We can do in a different way also. Suppose Q equal to 2n plus 1, P equal to 2n plus 3 because P must be greater than Q. We can choose any one of the set and let us find P square minus Q square, which is equal to 2n plus 1 the whole square minus 2n minus 1 the whole square. Let us remove the bracket. So 4n square plus 4n plus 1 minus 4n square minus 4n plus 1. Let us remove the bracket. So 4n square plus 4n plus 1 minus 4n square plus 4n minus 1. Now we can cancel the common terms because 4n square minus 4n square becomes 0. 1 minus 1 also is 0. So final terms are 1d 4n plus 4n. So which is equal to 8n. It's definitely which is multiple of 8. Which is multiple of 8. Hence we proved. See the next part of the question. Curve C has equation. Prove that C has no stationary points, which is very important. Which has no stationary points. If there is a stationary points, gradient of the curve which is dy by dx must be equal to 0. But this curve has no, we are going to prove which has no stationary points. So we have to prove dy by dx is not equal to 0. Or we can prove b square minus 4ac on the dy by dx must be less than 0 also. Then if it is negative, it has no real roots. We can prove the both method. So let's find out. Anyway, we have to find dy by dx to check whether it has the turning points or not. Stationary, the other name is other name of the stationary point is the turning point. So dy by dx equal to 3x square plus 24x plus 49. Now let's find whether this dy by dx is not equal to 0. So 3 times x square plus 8x. Now let us make a perfect square. So half of this 8 is 4. So let's add 4 square and minus 4 square plus 49. Now the first term is going to be 3 times x plus 4 the whole square minus 16. So minus 16 times 3 plus 49. Now this 16 is 3 times x plus 4 the whole square minus 48 plus 49. So which is equal to 3 times x plus 4 the whole square plus 1, which is definitely not equal to 0 because dy by dx is not equal to 0 or greater than or equal to 1. Or you can write dy by dx is not equal to 0 also. How it is working? At least if you make it, this term is 0 also, plus 1 is, which is anyway not equal to 0. So hence C has no stationary points. C has no stationary points. No stationary points. We can prove the other method, b square minus 4ac. So b square minus 4ac on dy by dx. The dy by dx is 3x square plus, so b square is 24 square minus 4 times 3 times 49. So which is equal to 576 minus 588. This value is equal to minus 12, which is less than 0. So here also we found dy by dx, that is b square minus 4ac is less than 0. So x has no real roots. X has no real roots. If it has no real roots, hence C has no stationary points. C has no stationary points. Stationary points. Hence we prove